It's okay.
Hello guys, welcome back to my channel. Now, as I've told you guys earlier, and I've exposed you guys to how to prepare a standard solution. With the little time I have here now, I would love to show you guys some likely questions in which we can come across with for the Neco practical. And how do you attempt any question given to you, irrespective of how the examiner places it. And note one thing, what you have on the board is just a guide. They said A is a solution of sodium hydrogen sulfate, which is of the unknown concentration. And looking at what you have on the board now, the methyl orange used. So, and again, let's say from your results and information provided, calculate the concentration of solution B in mole per dm cube. B, concentration of solution A in mole per dm cube, and C, the concentration in gram per dm cube of solution A. So how do you attempt that? It's very simple. Mind you, we have it on the board, and as I told you guys earlier, that in a titration like this, the titer value can range between 22.50 to 23 or 24.30. Anything from this, your titer value is wrong. So how do we attempt a question like this? The first thing to carry out is your rough titer. And provided you guys have yours, choose solution A and solution B. This is our solution A and this is our solution B. So with now, what you have here is a well-prepared methyl orange now. So now, let's move to the calculation part. The first thing to calculate is for you to know your average titer value. With that, we can say we have average titer value or volume of acid used. So how do we calculate that? You know, we have three titer value here. The rough titer value is what? Exempted. So we said first titer plus second titer plus third titer divided by 3. The reason why divided by 3 is because we are using 3 different titer values. If you are only using first and second titer, it shows it will be what? First titer value plus second titer value divided by 2. So now, let's pick the titer value or the average volume of acid used. So for the first one, we have 22.40 cm3 plus 22.50 cm3 plus 22.60 cm3 divided by 3. With that, like I said, we have so we have 22.50 cm3 now. So for it to have calculated for your average titer value, so now we can move to the question. They said the concentration of solution B in mole per dm cube. So we have said we have concentration of solution B in mole per dm cube. So class, what is our solution B? B is a solution, standard solution of sodium hydroxide containing 3.95 gram per dm cube. Note, anywhere you can come across any value in gram per dm cube, it stands as the mass concentration. So for us to know our what in mole per dm cube, you can say molar molar mass of solution B in the bracket sodium hydroxide. We are all given the value of each element, the mass number of each element. So now we can say 23 represents what? The mass number of sodium plus oxygen. We have 16 plus 1. So with this, we have 40 gram per mole. So now, how do we calculate the concentration of B in mole per dm cube? You can say molar concentration that's in, we have it in mole per dm cube is equal to mass concentration in gram per dm cube of solution B divided by molar mass of solution B. So, are you getting it now? So, with what we have on the board, class, so our mass concentration of solution B is given to be 3.95 gram per dm cube divided by the molar mass, which is this. So, we have 40 gram per mole. Mind you, the unit we have calculated for is what? Mole per dm cube. So, the gram, we cancel the what? The gram. So, with that, we can say we have 3.95 divided by 40. So we have 0.099 mole per dm cube. It means that we have those just to the first question that calculates the concentration of solution B in mole per dm cube. So this is step by step to show you guys how to calculate for it. So class, permit me, I would love to clear the board here so we can move to the next question, which states that we are to calculate the concentration of solution A in mole per dm cube. And how do we calculate that? Because they said A is a solution of sodium hydrogen sulfate of unknown concentration. We don't know the value of the unknown concentration of solution A. So how do we calculate for solution A? It's very simple. Mind you, you have not the value for your solution B in mole per dm cube. So the next one is we are also to calculate for what? Solution A in mole per dm cube. How? So how do we calculate for that? Mind you, it's very simple. Don't forget, the first thing to do is that you have to write out your equation. So it's that we can say our sodium hydrogen sulfate plus the base given. With that now, we can have this when combined with this, we are going to have sodium sulfate plus H2O. So now, what is the number of mole here, class? We will have 1 mole. The number of mole for the base is 1 mole. So with that, I can say I have Ca Va divided by Cb Vb is equal to Na divided by what? Nb. Mind you, your Ca represents the concentration of acid, your Va represents the average volume of acid used, while your Cb represents the concentration of the base, Vb the concentration of the base used. So class, from the question we are provided with either 20 cm cube or 25 cm cube of the pipette or the burette. Are you getting it now? So with what we have on the board now, we can say our Ca is unknown because we don't know it. It said concentration of solution A in mole per dm cube, which is going to give you earlier that our solution A is unknown. So the next one is the Va. Mind you, what you have on the board here shows you the volume of acid used, which represents our Va, and the value for that we carries what? 22.50 cm cube. So we have 22.50 cm cube. The next one, we have Cb. The concentration of B in mole per dm cube is given to be what? 0.099 mole per dm cube. So we have 0.099 mole per dm cube. Then our Vb is either we use 20 cm cube or 25 cm cube, depending on the value of this particular thing we use. So now, let's continue. Our Na represents the number of mole of the acid, which is this, 1 mole. We don't have any value here, so the number of mole here is 1. So we have this. Then the number of mole of the base is also what? 1. So now, with this now, we can decide to substitute for all the parameters given on the board by making our Ca, which is the concentration of the acid, the subject of formula. So with that, it's very simple. We decide to just cross multiply. We cross multiply. So it's that, like I say, I have CA, VA, MB is equal to CB, VB, and A. So now, what is that particular coefficient disturbing our CA? That is the, let's say the coefficient of CA is what? VA and what? MB is what, class?
VA and MB.
So divide both sides by VA and MB. So this cancel what? This now, you can see. You can say we have a CA. So what is our CB class? 0.099 mole per what? dm³ times our VB is what? So let's use 20 cm³ times our NA. We have 1, right? So class, what's our VA? 22.50 cm³, right? Times what? 1. Are you with me now? So with this now, it shows that you know what you are doing. Because in volumetric analysis, or let's say in titration, when it comes to the calculation part, you have to follow it step by step. So you won't run into what? Problem. So with this now, so this cm³ here, we cancel what? cm³. So now let's multiply all the value you have for your numerator and divide with what? Your denominator. So with that, we can say we have 0.099 times 20. We have 1.98 dm³. I mean mole per dm³, sorry. Divided by 22.50. So we have 0.088. Let's assume that, not even assumption, if we should replace our VB here with 25, so we are going to have, so we said we have 1.98, I mean let's say 0.099 times 25 divided by 22.50, we are going to have 0.011 mole per dm³, mole per dm³. That if you are using 20 as the average volume of the base used, we are going to have 0.088. But if you decided to use 25.00, we are going to have 0.11 mole per dm³ now. So class, the last one is the concentration in gram per dm³ of the acid. The concentration of the mass concentration in gram per dm³ of the acid in solution. So class, how do we know the value, or what is the formula for mass concentration? So we can say mass concentration in gram per dm³ is equal to molar count in mole per dm³ times molar mass in gram per mole. This is the formula for mass concentration. So now class, what is the mass concentration in gram per dm³ of solution A? Our solution A initially is what? Sodium hydrogen tetraoxosulfate. Class, what did I call it? Sodium hydrogen tetraoxosulfate. Again.
Sodium hydrogen tetraoxosulfate.
So now let's look for the molar mass of sodium hydrogen tetraoxosulfate. And say this. So our sodium mass number is 23 plus 1 plus 32. The mass number of sulfur plus 16 times 4. So we have 24 plus 32. 30 times 4 will give us 64. So with that, we can say we have 24 plus 32 plus 64. We have 121 gram per mole. So we have calculated for our gram per mole. And what is the molar count of the acid? Is it that we use this or we use what? This. Are you getting it now? So now, I will decide to use this because I use 20 in place for the volume of the base. So mass count, now mass concentration is equal to, the molar count is what? 0.088. Don't forget, you have it in mole per dm cube. And what is the unit of our mass count? Gram per dm cube times 121. So our value is 10.648 gram per dm cube. But if we are using 121 times 0.11, our answer will be 13.31 gram per dm cube. So the correct one to use is what? 0.11. Because when I show you guys how to carry out the standard or how to prepare a standard solution, I told you guys earlier that the value given for our sodium iron tetrasulfate is 12.7, if you can still remember, plus the value of the filter paper, which is given to be 0.7. So that gives us what? 0.34. So we are still in range. So 13.31, 13.32, 13.34, or 13.33. They are still in range. So class, it shows you guys that the average volume to be used is 25 cm cube. Again, is what?
25 cm cube.
Is what, class?
25 cm cube.
So I think I've justified the fact and show you guys the likely question in which you can come across with in your 2021 Neco practical. Don't forget to share, subscribe, like, dislike, comment, so we can show you guys the beauty behind chemistry. Thank you guys.